so this little demonstration is going to hopefully clarify any issues you are having with the civic and town car question. Now, in this little demonstration, I'm going to use my little orange car here. That's going to be my civic. It's going to be coming off of the cliff at a faster horizontal velocity. And hopefully you figured that out from the activity, the several questions. In this case, the golf ball is going to be my town car. Now, the town car does actually roll off with a small horizontal velocity compared to the civic, but just to keep things simple, I'm actually going to essentially make it a 0 horizontal velocity. I'm just going to drop it straight down. It's not going to have any horizontal component to its motion. That's just to make it easier for me, because what I'm going to try to do is I'm going to try to drop the ball at the same time that the civic leaves the cliff, so that we'll see which one spends more time in the air. That's going to answer one of those questions. And it's also going to answer which car lands farther horizontally from the cliff's edge to the landing spot. But it does take a little bit of doing, because it's tough to time with two hands, tough to get my left hand to drop it at the same time that the ball rolls off the cliff. But I'll give it my best shot. And again, I encourage you, don't take my word for it, don't take my demonstration for it either. Try this for yourself at home, but this is just a basic idea as to how you would set this up. All right, here we go. Civic versus town car. Let's try it again. I dropped the one a little faster that time. Do you hear? They hit at the same time. Both cars spend equal amounts of time in the air. Why is that? Because they go equal amounts vertically. And if you recall from your Newton's second law stuff, when they're both in the air, the only force that is acting on them is gravity. They're both in free fall. And that means they're both being accelerated the same amount. They're both being accelerated at g. It doesn't matter the size of them, it doesn't matter the mass of them. All objects in free fall, we're going to ignore air resistance. All objects are being pulled down at a rate of g. And since they're both falling vertically the same distance, if the acceleration is the same and the distance is the same, the time of fall should be the same. Now, you should have noticed also that my my civic landed farther horizontally from the base of the cliff than my town car did. Well, that makes sense as well, because the civic had a much larger horizontal velocity than the town car did, and therefore the horizontal velocity doesn't change, even though we're adding vertical velocity as the thing falls. Its horizontal velocity continues to take it this way, and therefore the civic travels a greater distance from the edge of the cliff.